Hello everybody, my name is Melita Kennedy and I work as a product specialist here at USRI in Redlands, California. With me today is my colleague Ian Sims, who is going to help me answer questions. He has also worked as a product specialist on the ArcMap team in ArcGIS and now works as Quality Assurance Manager for both ArcIMS and ArcGIS. I want to welcome you all to today's live training seminar. The presentation today is Working with Map Projections and Coordinate Systems in ArcGIS. The subtitle for this presentation is Help, My Data Doesn't Line Up. I'm sure this has occurred to a lot of you just as it has happened to me. We have three main topics. The first is what are geographic and projected coordinate systems. The second one is identifying an unknown coordinate system. And the final topic is warning messages, and these are warning messages that occur that are coordinate system related. Each topic will include a software demonstration, a review, and optionally a question and answer period. The first topic is what are geographic and projected coordinate systems. I know a lot of you will already know this information. This is just to make sure everyone is starting out at the same level. Don't worry if it's a lot of information and it might be a little confusing. Just kind of try and remember what you can and go with the presentation. So geographic coordinate system defines a three-dimensional coordinate system that's based on the Earth's surface. The definition contains an angular unit of measure such as degrees, a prime meridian, and the prime meridian defines the origin of the longitude values, and a datum, which in turn contains a spheroid or sphere definition. Because almost all geographic coordinate systems use degrees as the angular unit of measure, the x or longitude values will range between minus 180 and plus 180 degrees, while the y or latitude values will range between minus 90 and plus 90 degrees. Some examples of geographic coordinate systems include WGS 1984, NAD 1983, and ED 1950. These are just examples. You don't need to remember these. I just wanted to give you some samples so you can see what the terminology is. Here's a diagram to help further explain geographic coordinate systems. If you look at the lower right part of the diagram, and in the lower part of the diagram there's a long green horizontal line. This is an angular distance of 60 degrees of longitude, and you can see it's a pretty significant length. If you now look on the left side of the diagram, there's an orange or red vertical line. This is the same angular distance, 60 degrees, but and it's about the same length as the 60 degrees longitude at the equator. The green horizontal line at the top of the diagram is the same angular distance, 60 degrees, but because it's at 60 degrees north latitude, the length is only 2/3 that as the same angular length at the equator. So just remember that when you're working in a geographic coordinate system, depending on where you measure that angular distance, the actual distance on the ground may be different. So now we have our first review question. Which of the following units cannot be used for a geographic coordinate system? A, degrees, B, radians, C, meters, or D, seconds? And please click the review question link on the left to choose your answer, and I'll give you the answer in a few slides. Now, I want to discuss a little bit more about datums versus geographic coordinate systems. A datum is really the main chunk of a geographic coordinate system. It's a network of control points that are tied to the Earth's surface. And a lot of times you'll see the terms datum and geographic coordinate system used interchangeably. But what really is datum is the network of control points, and when you add more information to it, such as an angular unit of measure and a prime meridian, that then creates a complete geographic coordinate system definition. And you should try and use that terminology, a geographic coordinate system, when you're talking about what the information is on your data set. Now, a projected coordinate system defines a two-dimensional planar coordinate system, such as a map, paper map, or what you would see on your screen. It contains a complete geographic coordinate system. So a projected coordinate system inherits all that information, the datum, the angular unit of measure, although it's not used per se, and the prime meridian. It also has a map projection, and by map projection I mean the actual mathematics that will be used to convert the data from the three-dimensional Earth into the two-dimensional plane. Any parameters that are needed by the map projection, and then a linear unit of measure such as meters or feet. The UTM and state plane are examples of projected coordinate systems. Now again, just like the term datum, the term projection is often used but is incorrect. It's hard to get away from that. It's a lot easier to just say projection than projected coordinate system or geographic coordinate system. And ArcView GIS version 3 and ArcInfo Workstation both use the term projection, so it's hard to not use that term. But in ArcGIS, we do try and use coordinate system, and I recommend you also switch to that because it is a more accurate term. So here's a diagram for projected coordinate systems to help explain a little bit more about them. You can see there's two axes, an X and Y axes, and the upper right corner is shaded, and in that part of the diagram, the X and Y values are going to be positive because where the X and Y coordinates meet, that's where your 0, 0 point, and that's usually defined by, let's say, your central meridian and your latitude of origin parameters. Now, the data usually isn't going to be in that upper right box so that all the values are positive. And the way that is actually done is what people will do is that basically the origin of the projected coordinate system, they'll set what's called a false easting and a false northing parameters. They'll actually set that center point, which is originally 0, 0, to two very large numbers so that all the data in their area of interest is all going to have positive values. That's really a holdover for when people were working with paper maps and were doing calculations by hand. You don't want to have to worry about, is the number positive or negative, and did I do the sign right when I added it or subtracted the value? But now that we do most of our work on computers, using a false easting and false northing parameter is much less necessary than it used to be. So now I'll go ahead and give the answer to the review question. Which of the following units cannot be used for a geographic coordinate system? And it looks like almost everybody got it right, it's over 75%, and the answer was C, meters, because meters is a linear unit of measure, not an angular unit of measure. So now we'll have our first review and Q&A session. We talked briefly about geographic coordinate systems and what's contained in the geographic coordinate system. We talked about datums and how that is part of a geographic coordinate system but is not actually the same thing. And then we also talked about projected coordinate systems and talked about false easting and northing parameters. So now I'll turn it over to Ian to help answer your questions.
Okay. Jim from Houston asks, if data is projected on the fly, what issues arise with not editing in the native or original projection?
It depends on the coordinate systems you're working with. If you're working with two coordinate systems that are really appropriate for your data, let's say your data is in a UTM system and you're projecting it on the fly to a state plane system, then you really should not have any issues. If instead you were taking data that was originally in a UTM zone, let's say zone 10 in California, and you were projecting it to a UTM zone, say 13 or 14, which is quite a long ways away and is not appropriate for your data, then you might see problems when the data is edited and then unprojected back to the original coordinate system. But as long as you maintain your work in a coordinate system that's appropriate for where your data is, you shouldn't see any problems with editing it and projecting it on the fly.
Brian from Kansas asks, do you have to do anything special to get ArcMap to convert different coordinate systems to the same one? Do you specify the one you want them to be first? That is correct. That's what you do. The first data set that you add to ArcMap is the first one that will define what the coordinate system is that the data frame is going to use. And all subsequent data sets that are added are then projected on the fly to match that first candidate. So really the only thing special you have to do, Brian, is add the first data set that you want to set the rule and then just add the rest of the data. And providing all the data sets are defined correctly, we'll get into that a little later in the presentation, you should have no problem selecting which coordinate system you want.
One of the questions was, can I tell, Jeremy from Portland asked, can I tell ArcMap not to project on the fly? And yes, you can, and I'll go ahead and I'll show that to you when I do the first software demonstration. So I'm going to go ahead now and go on to my next topic, which is kind of the main one of this presentation, which is identifying an unknown coordinate system. So why doesn't data line up? There's two main reasons why that may occur. One is that there is no coordinate system information on the data itself. If the coordinate system information is available for a layer, ArcMap can automatically convert between coordinate systems. If the coordinate system information is not there, the data is simply displayed and cannot be reprojected. The other possibility, which is infrequent but definitely can happen, is that a data set may actually have an incorrect or wrong coordinate system definition. And I mean, I have down that it's infrequent. I see a lot of data, so I see it probably 2 or 3 times a year, maybe every several months. I did talk to one of my colleagues in technical support, and she says out of 30 calls a week, she may see it 1 to 2, maybe 3 times. So it does happen, and it is pretty easy for it to happen. Let's say you're working with a lot of data, it's all in the same coordinate system. You get new data, and you just assume it's in the same coordinate system, so you go ahead and define that the same as your other data, and without double checking to confirm that that is the case. So just be aware of that. So I want to talk briefly about the scenario I'm going to show in the software demonstration. We have street data for Indiana and Michigan. This is in the U.S. The Indiana and the Michigan data are already in the same coordinate system. We have new Ohio data that does not line up with the existing data. So what we're going to do is we're going to check the coordinate systems for all the data, and then also take a look at what it looks like compared to the known data. One way to check the coordinate systems, and this is a quick way to do it in ArcMap, is to use the coordinate system tab of the data frame properties. And I'm going to go ahead and explain this dialog when I'm in the software demonstration. So the other thing to do is you always want to look at your data. That's very important. So in this diagram, I kind of show you some of the things that may happen when you're dealing with data that has an unknown coordinate system. So right now we basically have 2 boxes, maybe say 2 polygons to cover the same general area on the ground. And you can see that the Y values are pretty close. One is at 4.1 million units, and the other is at 4.1 million plus 123 meters, let's say. So they're relatively close. If you see that occur with known and unknown data, that generally means that the geographic coordinate systems are different. If instead we have, let's say, one of the polygons is at 4.1 million meters Y value, and the other one is the Y value is closer to 100,000 meters, then we know that these are really in different projected coordinate systems completely. Now let's say that our dark blue box in the lower left is our known data, so the Y values are at about 100,000. And now we have new data that we add that doesn't have a coordinate system defined. And you look at it, and the relative extent, the relative area of the 2 data sets is very much different, even though these represent the same area on the ground. So if you see data that's much larger or smaller than known data, and both of them represent the same area, then you know you're dealing with a different unit of measure. Perhaps one is using meters and the other is using feet. So now I'm going to go over to ArcMap and do the first part of the software demonstration. I already have my map document open, and I have 2 layers. Michigan roads is in blue and Indiana roads in purple. So I'm going to add in my Ohio data and see what happens. And I got a warning message. The warning message is 1 or more layers is missing spatial reference information. Data from those layers cannot be projected. So we already know data doesn't have a coordinate system defined on it. So I'm going to go ahead and open up the data frame properties, and that's by right-clicking on the layers, and go look at the coordinate systems for these layers. Sometimes you may not get that warning message. If you've been working in ArcMap, perhaps you've gotten it once. It may not show up if you add more data that does not have a coordinate system defined. And also, if you drag and drop data in from our catalog, you also may not get that warning message. So I've opened up the data frame properties, and I'm on the coordinate system tab. In this upper left box is the current coordinate system of the data frame, and the name of the coordinate system is also listed in the bottom left box under the custom directory. There's a few other directories here, favorites, predefined, and layers. I'm going to open up the layers directory, and you can see each of the layers is listed in ArcMap. If I now select these, the name of their coordinate system is listed. So you can see the Michigan and Indiana data are both using NAD 1983, UTM Zone 16 North, while the Ohio data is listed as being unknown. So I'm going to go ahead and OK this dialog. And now I want to go and I want to see where this Ohio data is relative to my known data. So I'm going to go click on Full Extent, and you can see that the Ohio data is very far south relative to my known data, my Michigan and Indiana data. So I'm going to use the Measure tool to see approximately how far away it is. So I'm going to click down there on the Ohio and drag up to about where it should be. And when I double click, the answer is down in the lower left part of the ArcMap, and you can see it's over 4 million meters away. So it's quite a ways away, so we know that it's definitely in a different projected coordinate system. Now remember, the other thing to look for is the relative area, the relative size, extent of the data, of the unknown versus the known data. Now all of these layers cover about the same relative areas. And I can see that the Ohio data, the size is about right compared to my known data. So I know it should be using the same units as my existing data. My Michigan and Indiana data is using meters for their units, so I know this Ohio data is also using meters. So now I'm going to go back to the presentation, do a few more slides, talk about what I'm going to do next, and then come back to the software demonstration. So a quick review here. Why doesn't data line up? It could be that the layer is either missing the coordinate system or the coordinate system is incorrect. And we talked about how do you check the coordinate systems, that the quick way is in ArcMap using the Layers tab. And then also, where is unknown data? So remember that when you're trying to figure out the coordinate system for unknown data, you want to both look at where it is and how large or what the extent is relative to your known data. So when you work on identifying a coordinate system, we can use ArcMap as kind of a shortcut to help us identify it. Remember that ArcMap, if the coordinate system information is known, can reproject data on the fly to a new coordinate system. So what we'll do is we'll set the data frame to a new coordinate system that we think our data might be using, our unknown data, and see if we can ever get the known data to line up with the unknown data. If we can, then we know we've now identified the coordinate system of our unknown data. It is the coordinate system of the data frame. If the first time you try it doesn't work, then try and have other candidates available and try those and see if you can get the data to line up. If it does work, then basically we're finished, but we need to go ahead and add that coordinate system information to our data set. The first thing you need to do is you need to remove the layer from ArcMap, because ArcMap has a lock on it, and if it's in ArcMap, I cannot update the coordinate system information. At that point, you can assign the coordinate system of the data frame to the layer either in ArcCatalog or ArcToolbox. I'm going to be using ArcCatalog. In ArcToolbox, at version 8, there's a wizard called the Define Projection Wizard. And what that does is exactly what we're doing in ArcCatalog, where all it does is update the metadata of the layer. All it does is add the coordinate system information as metadata to the layer. It does not actually change the coordinate values of the data. There's another tool in ArcToolbox called the Project Wizard. That is where you would actually, if you wanted to change the extent, change the coordinate system of your data to something new and update the coordinate values of the data itself, you would use the Project Wizard as opposed to the Define Project Wizard. Now what happens if that doesn't work? We can't seem to get this unknown data to line up with our known data. Well, at that point you need to do research for more information. One thing to do is to look at the metadata. Not necessarily what all is shown in ArcCatalog, but the actual metadata files themselves that may be with the data. Sometimes there'll be a processing history or just what's been done to the data. Someone may have written down what coordinate system it was at one point. The best thing to do is to go back to your data provider or source. If a colleague gave it to you, go back to your colleague and try to get them to tell you what it is. If you found it on a website, check other web pages on that website. The information may be there, but no one actually just pushed that information to the data itself. Another thing to watch for are similar data types. In the U.S., for example, there's a lot of data that comes from the 1 to 24,000 quadrangle map sheets. And all that data generally uses the same types of coordinate systems, so those would be the first things you would want to try. So if you research and you know that your data came from a particular data type, try and do maybe a general web search and see what's used with that data and try that first. The other thing to do is to use various databases and use various help files to try and figure out what coordinate systems are used in your area of interest. And I'll give more information about those later in the presentation. The other thing to watch out for is how do you find the coordinate system information for the various data types. Each one lists the information in a slightly different way in our catalog. Look for the term spatial reference, projection, or coordinate system as a clue as to where this information is to be found in the properties of a data set. And I'll show that for shapefiles into your database when I do the rest of the demonstration. Now in our catalog, you can only view the coordinate system information, and then you can change it. So what you do is you select a data set, click the metadata tab, and then click the spatial tab, and I will show this in the demonstration, and there it will list the coordinate system information. If you want to change it, again, you can do it in our catalog, which is what I'll show. Open the data's properties, and then you can work through and find the coordinate system information. There will usually be an edit button or an ellipse button that'll let you go ahead and update the coordinate system information. Again, all this does is update the metadata. It doesn't actually change the coordinate values of your data. So now I'm going to go back to ArcMap and try and figure out the coordinate system of this Ohio data. So the first thing I'm going to do is I'm going to open up, again, the data frame properties. And what I'm going to do is I'm going to open up here the predefined directory in this lower left box. What ESRI has done is we've gone ahead and defined for you a whole set of coordinate systems that are in use around the world. So I know that this data is in a projected coordinate system, so I'm going to go ahead and select that. The first entry is continental. Those are coordinate systems that are used for, let's say, all of Europe or all of North America, so it's a pretty unlikely choice. The next one is county systems. These are new at version 9, and these are for both Minnesota and Wisconsin, so again, it's unlikely for Ohio data. And I am using version 9 of ArcGIS, so what I see in this dialog will be different than if you're using version 8. We've added more entries here than what you have available. The next one is Gauss-Kruger. This is a projected coordinate system that's very similar to UTM, but it's used in Europe and in Asia, so again, pretty unlikely. The next entry is national grids. This is kind of a miscellaneous directory. It contains coordinate systems used around the world, including a few for the U.S., but again, it's pretty unlikely this Ohio data is using that. The next one is polar. This is for the North and South Pole areas. Again, I can skip this one pretty safely. But the next one is state plane. And in the U.S., if a data is in a projected coordinate system, it's almost always either in UTM or state plane. So I'm going to go ahead and open that up. Now, in the state plane directory, we have more subdirectories. These are divided by the geographic coordinate systems. So this first entry is NAD 1927. That's kind of the older geographic coordinate system for North America. This data is pretty recent, so it's unlikely it's using this. The next one is NAD 1983, and this directory, although it doesn't say so, all of the entries in here are using meters. So it's very possible that my data might be using this one. NAD 1983 is very common in the U.S. for data. If you have very, very recent data, it's also possible it might be using NAD 1983 HARN. This is a readjustment of data that's occurred in, let's say, the last about 10 years or so. And this data isn't that recent, so I'm going to try NAD 1983 first. Now, there's over 120 zones in here, so I'm going to have to scroll down quite a ways to get to any Ohio listings. So right here I've got two for Ohio, Ohio North and Ohio South. I am working in the north part of the state, so I'm going to go ahead and try Ohio North and click OK. Now it looked like the Ohio data jumped north to match my Michigan and Indiana data. What really happened is the Ohio data stayed where it was. So for instance, you can see my Y values are about 200,000. The Michigan and Indiana data actually were reprojected on the fly into the Ohio North coordinate system. So if I go ahead and click full extent, they look like they're lining up very well. So I'm going to go ahead and zoom in a little bit here and see if these things really are lining up well. So I've zoomed in now to 1 to 139 in my map scale, and you can see that the data here for Ohio and here for Indiana are lining up extremely well. So I've now identified the coordinate system of this data set. It is NAD 1983, State Plane, Ohio North. Now we had the question earlier about how do you turn off projection on the fly. So I'm going to go ahead and show that. So I'm going to open up the data frame properties again. And you see on this upper right of the dialog here, there's a clear button. So if I now clear this, you can see the current coordinate system says no projection. If I OK or apply this dialog, the data again will basically jump apart because the UTM data will be, the Michigan and Indiana data will be in one location, the Ohio data will be in another. But I don't want to do that. So I'm going to go ahead and select the Ohio North coordinate system again and OK the dialog. So I'm going to remove the Ohio data from the data frame, from ArcMap, and I'm going to go over to our catalog and define its coordinate system. So I've already browsed my data, so I select Ohio roads, and I'm going to right-click on it to open up its properties. Now here's an instance where this data type kind of hides the coordinate system information. There's 3 tabs here: General, Fields, and Indexes. On the Fields tab, click the shape field name, and you'll see in the bottom of the field properties is a spatial reference. And I will talk a little bit more later about the difference between spatial reference and a coordinate system. You can see currently it's listed as unknown. So I'm going to select that little ellipse button on the right, and I now have the spatial reference property page open. Now if I had other data that was already using this coordinate system, I could use the import button and basically copy the information from my other data. Or if I needed to define a coordinate system from scratch, I could use the new button. But I know this is already available, and I'm just going to use the select button to browse to it. So you're going to see the same type of directory structure you saw on ArcMap. So I'm going to go into Projected Coordinate Systems, State Plane, NAD 1983, and then I'm going to scroll right to get to the Ohio North data. So I select that and click Add. You can see now that the information is listed here in the details. So I'm going to click OK, and again now on the spatial reference you can see that the name is listed. So I'm going to OK again. Now remember that I said you can also look at the coordinate system for the metadata. So if I now if I go over and click on metadata, and now on the spatial tab, you can see here also the coordinate system is listed. If you scroll down a little bit, you can also see the bounding coordinates. We list, if a data set is in a projected coordinate system, we list the extent both in decimal degrees and in the projected or local coordinates. So here is the extent in state plane coordinates, and here is the extent in decimal degrees. If you suspect a data set is using an incorrect coordinate system, this is the first place to look. Because what will happen is that if the coordinate system is defined incorrectly, when we are calculating this decimal degree extent, the values will not match where the data should be on the Earth. And I keep atlases on my desk where I can look up where data is supposed to be in the world and see if the decimal degree extent of the data matches where I think the data should be. And that's the quickest way to see that, oh yeah, this thing's showing up in the Atlantic and it should be in New York. It must be in the wrong coordinate system. So now I'm going to go back over to ArcMap and add in this Ohio data again. So again, it lined up well. I'm going to go to full extent. It still lines up. But now I'm going to go back to my original coordinate system. So I'm going to open up data frame properties again. And remember, the quick way is to go into layers, select one of the layers that uses the coordinate system you want to use, in this case UTM, and click OK. And now my data frame is now using the UTM coordinate system. The Ohio data, now that it has a proper coordinate system definition, was projected on the fly to match my existing data. So now I'm going to go back to my presentation and do a review and more questions and answers. So we talked about identifying the coordinate system. How do we do that? and then what to do if you can or cannot get it to work. And we also talked about how do you find the coordinate system information on a data set when you need to update it. And now I'll turn it over to Ian to help answer some of your questions.
Well, Lisa Marie in Sydney is asking, can we reproject images on the fly? And the answer is yes, you can do that. What I'd advise, though, is you concentrate on images that are fairly large-scale areas, because, as you know, the ramifications of largely distorting images at a global scale can sometimes look a little ugly, especially in the earlier versions of the earlier 8x versions of ArcMap. So yes, you can reproject images on the fly as well as vector data.
For version 9, we have been working, it's been kind of a major project to kind of rework how we project images on the fly. When it works, it's really, really cool because we've had worldwide rasters that we can project into coordinate systems and have it look really good. Not anything like what you would see in ArcInfo Workstation or in ArcPlot. So I think when some of you start seeing this when version 9 is released, that it'll be very interesting.
Samantha asks, what is the difference between NAD83 and WGS84, and are they actually interchangeable, as some people say? That's largely correct. Yes, they are largely the same and largely interchangeable, especially when you're dealing with an area of interest in North America. But there are differences, of course, between NAD83 and WGS84 and other places on the globe. So, again, in large cases for North America, that is essentially correct.
It really only matters if you're doing a really high-end survey. If you're doing geodetic level survey, then you may need to worry about the difference, but it is pretty minimal.
Paul asks, if you know the coordinate system, is it okay to copy the PRJ file from a known layer to the new layer and rename it identically to the new layer's file names? Or does using the wizards to define projection do more than create the PRJ file? Well, I know that you're talking about shapefiles there, Paul, and I know that's something that a lot of us old-timers are used to doing. So, yes, it's okay to copy that PRJ if you want to do it that way. There's other ways to do it, though, through the UI, and also you can go ahead and import an existing PRJ through the UI to apply to another data set also. So we've given you that flexibility.
If you're talking about a lot of data, which I know sometimes that's when people do this, they copy the file through Explorer. There are some ARC scripts. There's on our website, there's arcscripts.esri.com, where people have written tools that will batch define the same coordinate system to multiple data sets. And you may want to look at that if that's what you're having to deal with. There's kind of a related question from John in Edmonton. By defining the spatial reference, will this create a PRJ file? And basically the answer is yes. A PRJ file and a shapefile generally is only the coordinate system information. Other data types will store this information elsewhere. But when you go ahead and you define a spatial reference, that will include the coordinate system information. So right now I'm going to go ahead and go on, and we will have time at the end for more questions. So my final topic is warning messages, oh my. And I really wanted to emphasize that a lot of these messages are warnings. You may or may not need to do anything more about them. You just need to be aware of when they occur and why they're occurring. So we've already seen this message, the missing spatial reference message. You get this in ArcMap when you add a layer to ArcMap and it does not have any coordinate system information. If you're lucky, the data that does not have a coordinate system information may truly be in the same coordinate system as your other layers. If that's true, it's going to go ahead and line up fine. The only problem you will have is if you then need to reproject on the fly, that data will now suddenly not line up when you go to the new coordinate system. Another thing to watch for is if you have a shapefile or a geodatabase data that shows up with this coordinate system, GCS assumed geographic 1. The way to remember this is not that it's assumed geographic, but that assume that it is wrong or assume that it is incorrect. It's really a fake coordinate system that we assigned to shapefiles if the x values are between plus and minus 180 degrees and the y values are between plus and minus 90 degrees. So it's like if the data looks like it's in decimal degrees, we'll go ahead and give it this coordinate system. All this does is allow the data to be projected in ArcMap, and this was to help people coming from ArcView GIS version 3 that may have data without a PRJ, without a coordinate system definition, to let them go ahead and add the data and then reproject it on the fly. Because this is a fake coordinate system, it has no defined transformations for it, no defined geographic datum transformations. So it very likely will never line up correctly with data that has a known coordinate system on it. So now we're going to do a second review question, and this is really on our last topic, or our previous topic, I mean. New data without a coordinate system appears over 3 million units away from your existing data. Which of the following is possible? A, the projected coordinate systems are different. B, the geographic coordinate systems differ. C, the units of measure are different. Or D, all of the above. Please click the review question link on the left to choose your answer, and I'll give you the answer in a few slides. Now, this is kind of a big warning message, a big box with a lot of text in it, so I'm going to go ahead and read that. You add data to ArcMap, and you may get this warning box. It says, the following layer has a geographic coordinate system that differs from other data in the map or from the current map projection, and that should say the current coordinate system of the data frame. You may need to select a different geographic transformation than the one automatically chosen for you in order to avoid alignment or accuracy problems with the data. What that really means is exactly what it says. Somehow there's a difference between your other layer or the ArcMap data frame coordinate system that they're using different geographic coordinate systems. And you may get a bit of a shift if that occurs in your data, even when you're reprojecting it. Now we do define one transformation by default. That is NAD 1927 to NAD 1983 using the NADCON method. This is the most accurate method for the lower 48 states of the United States. If you're working in Canada, Alaska, Hawaii, or using any other geographic coordinate systems, you will need to go in and set a geographic transformation because those are not automatically applied. So on this dialog, there's two buttons, an OK and OK to all button. I just always use the OK button. And there's two checkboxes. The first checkbox says, don't warn me again in this session, and that means that while this ArcMap session is open, if you check this, you'll never see this warning message again, no matter how much more data you add to ArcMap. The second checkbox says, don't warn me again ever, and ESRI really means it when we say that. If you check this, you will never ever see this dialog again while you have this version of ArcInfo installed on your system. To turn it back on, there is actually an executable in the ArcGIS Home in the Utilities directory called Advanced ArcMap Settings. It does change a registry setting, so you have to have permissions in your login to change your registry. If you try and change this to either set it or don't set it, and you can't seem to be able to do it, you may need to talk to your IT or your systems department to help you get this changed. So let's say we've gotten that message that we do need maybe to set a new transformation for our data. That is available on the Coordinate System tab in the Data Frame Properties, and on the right in the middle of that dialog is the Transformations button. So if you click that, you get this dialog. And there's basically three boxes. The top box lists any unique geographic coordinate systems for your data. In this case, we have two, North America 1927, which is the same as NAD 27, and North America 1983, which is the same as NAD 83. The second box, the Into box, is a data frames geographic coordinate system. In this case, it's North America 1983. And this is a pull-down box, but you should leave it the where it is. You should not change it. The bottom using box lists any predefined geographic coordinate systems that we have available, ESRI has available, that go between these two coordinate systems. In this case, NAD 1927 and NAD 1983. Now, geographic transformation always has a directionality. As you can see in this pull-down box, they're all from NAD 1927, and they go to NAD 1983. Even if you were going in the other direction, like let's say you wanted to convert from NAD 1983 into NAD 1927, you'll still see the same list. the user interface in the software is smart enough to look at what you want to do and define and actually apply the transformation correctly. So you don't need to worry about the directionality in here. If you're working in ArcObjects with perhaps the ProjectEx method on a geometry, then you'll see that there is a parameter that tells you you need to set the directionality. So you just need to be aware of that if you're programming as opposed to working with the user interfaces. So I'm going to go ahead and give the review question results. The question was, new data without a coordinate system appears over 3 million units away from your existing data. Which of the following is possible? The answer is D, all of the above, and it looks like majority of you got it right. 75% of the people who answered got it right. And this really puts kind of a trick question. I didn't give you enough information in the question for you to make a good decision. All I said was that it's 3 million units away, so that definitely means a different projected coordinate system. We could also have a problem with the geographic coordinate systems, and I did not tell you the relative extent or size of the data, so you could not decide whether or not the units of measure were correct or whether they're different. Another message you may get, particularly when you're editing or when you're importing data, is a coordinates are out of bounds error message. This generally occurs with geodatabase data, and it means that the spatial domain of the target feature class is too small. And I'm going to go ahead and explain what I mean by that. There's a difference when we use the term coordinate system versus spatial reference. The coordinate system is always going to be projected or geographic, and that basically defines how these coordinate values of your data are defined and how they're linked to the Earth. A spatial reference includes a coordinate system, plus it adds what's called the spatial domain or the XY domain. We also use domains with measures and Z values as well, but mainly we're concerned here with the XY domain. Spatial domain actually has two parts. Basically the extent, the minimum and maximum X and Y values of your area of interest, and then a precision or scale value. The precision or scale value I always think of as how many decimal places can I support with my coordinates when I store it in a geodatabase. So here's a diagram to help try and illustrate that. In the lower left corner I have data in decimal degrees. Even if that data covers the entire world, the extent of my data is going to be pretty small. It's going to range between plus and minus 180 degrees in X and plus and minus 90 degrees in Y. If I had data that in UTM that was using meters for the units, my extent is going to be much larger because I'm working now in meters and on a projected coordinate system. So my X and Y extents may be in the hundreds of thousands of meters for the extent. That means that my precision is going to have to be smaller to take into account the fact that I'm using a larger extent. If instead the data is now using feet, let's say it's in a state plane coordinate system, now my extent is going to be 3 times as large as the same area in UTM, which means in turn that my precision value is again going to have to be even smaller than it was when I was working with UTM and in meters. So what I want to do is I want to go over to our catalog and kind of play around with the XY domain and show you how that works. So what I'm going to do is I'm going to go to one of my personal geodatabases, and I'm going to right click on it so I can create a new feature class. So I'm just going to type in a name, and the type is fine. I want it to have simple features. I'm going to use the default configuration keyword. And then again, I need to start working with the spatial reference. So again, this is like a shapefile. I want to click on the shape field name. And at the bottom, there's a spatial reference, and currently it's unknown. So I click the ellipse button, and I'm going to go ahead and set the coordinate system. I'm going to use the select button, double-click on geographic coordinate systems, and I'm going to use world, and then select WGS 1984. Click Add, and you can see now the information is listed here in the details. And I'll switch over to the XY domain tab. These values are the default values you see for the XY domain, and they really are not good for any coordinate system. They're okay for geographic coordinate systems because the extent's large enough to include the data that would happen to be in decimal degrees. But if you look at the precision value that is here, it's only 100,000, and that's really not large enough to adequately store data that's in decimal degrees. So what I'm going to do is I'm going to go ahead and increase that value to 1,000,000. And I clicked out to have the other values updated. And you can see the max X and Y values are now at a little over minus 7,000. So now my data won't fit into this extent anymore. So what I need to do is I need to change the minimum X and minimum Y values to help to make my max X and max Y values large enough to fit my data. So my minimum X value I'm going to make minus 200. That's still too large, but it's a lot closer to what I'm actually using. And then I'm going to make my minimum Y value minus 100. And you can see now my max values are now big enough that I can store all my geographic data. These are really still too large, but at least I'll be able to get all my data stored. There's also a button here that says about setting the XY domain. There's quite a lot of good information in here at version 9, and I recommend you read that. I'm sure some of you might have the question, well, how do I figure out what values to use here in the XY domain? I mean, let's say I'm using UTM or state plane. The easiest way I do it, which is basically to cheat, is I just add the data ArcMap, put it in the coordinate system I want, and then use ArcMap to basically move my cursor around and see what the minimum maximum values are. You always want to add a bit of extra to the domain. In the future, if you need to add more data and you happen to be outside the spatial domain, you're not going to be able to add it. The editor's not going to let you, because this is basically hard-coded into what's stored in the geodatabase. You will have to create a new feature class with larger XY domain and import your data into the new feature class in order to edit it if you want to use something bigger than your existing XY domain. So make sure you always give a bit of an extra area when you set up your XY domain. So I'm going to go ahead and click OK there. And I don't want to create this feature class. I'm just going to cancel at this point. And I'm going to go back to my presentation. So now we're in our final review and question and answer session. We talked about various coordinate system warnings, including the missing spatial reference warning if your data doesn't have any coordinate system information. We talked about the assume it's wrong coordinate system, assumed geographic 1. We also talked about the warning message about different geographic coordinate systems. You may need to set a geographic transformation message. And then we looked at how do you set a geographic transformation. We also talked about when you get a message about coordinates are out of bounds and what to do about that. And that led us into speaking about the coordinate system versus the spatial reference in the XY domain. So now Ian and I will answer a few more of your questions.
Guy actually has a very interesting question that I know a lot of you have asked today, and that is, how can we add projection information to a layer that we drew by ourselves? And the answer to that is, I think, one of two ways. If you drew the layer by yourself over an existing data set within ArcMap, then it would be, and it is of the same area, you would then be able to copy the projection information from the base data set that you digitized over to the new one that you created in the properties dialog of the new data set, which would be one way to do that. Now, if you're adding projection to a layer that we drew by ourselves, what you're going to need is you're going to need a ground truth coordinate for that data. There is absolutely nothing we can do to help you unless you truly know what at least let me give you an example, 3 or 4 ground truth positions are on your data that can be used to what's called register the data into a known coordinate system. Now, if you're lucky enough to have a GPS, you can go out into the field to a specific known location that you've digitized and get a very accurate base location for that. Or you can maybe refer to a topographic map sheet that also has a grid of high accuracy predefined coordinates laid down that you can transfer over. That's a little bit of a convolved answer, but I did want to make sure we gave a brief discussion on that, because I know several of you have asked that question this afternoon.
Sumant from Pearl River has a question. Could you please go over false easting and false northing again? Basically, all false easting and false northing does is basically add a shift to your data values. So let's say you define a coordinate system. Let's use UTM, for example, because this is a very common coordinate system. the center point for a UTM zone is the central meridian and the equator. So let's say we have a zone 31 in UTM has a central meridian of plus 3 degrees, 3 east. So the 0, 0 origin of that coordinate system is at where the 3-degree longitude line crosses the equator. Now, a UTM zone is generally 6 degrees wide, so basically any data between 0 and 6 degrees longitude would be used in this UTM zone 31. So what people wanted to do is they wanted to make sure that all the x values in the zone were going to be positive. All the longitude values, when you project to x values, will be positive. So what they did is they let the false easting value be set. They decided that they could set it to 500,000 meters. And that means now that the most west, you can go in the zone. So let's say you're at 0 degrees longitude. That x value is going to be about plus 200,000 meters. So that means that all the data in the zone will be positive. Now that's only if you're working north of the equator. UTM actually has north and south zones. If you're north of the equator, now remember the origin is at the equator, so all the y values are by default positive, so the false northing is 0. You don't have to add one because everything's already positive. If you're working in the southern hemisphere, the origin is still at the equator. So what people do is they add a false northing value of 10 million meters at the equator, which means that anything in the anything south of the equator will still have a positive y value. I hope that helps answer your question.
Richard from Oakland's asking that he's received data from a client with a coordinate system defined as custom, but he needs to project it to California State Plane. How should he proceed?
As long as the coordinate system definition is there and only the name is marked as custom, I have a feeling this data was actually worked on in ArcGIS version 3 in the projection utility. That utility, if you had a coordinate system that was not predefined, not already defined by ESRI, would always use custom as the name. And also if you define one even in ArcGIS, that's like kind of the default name we give as custom. But as long as everything is there, that the data information, the parameter values are there, you can go ahead and just let it be called custom and go ahead and project it using one of the tools or using ArcMap on the fly to get it to California State Plane.
Samantha asks, we've been converting our corporate database from NAD27 to NAD83. Occasionally, when I open a file, it ends up very far away, even though there is only a 300-foot difference. Why? Well, hopefully we've given you a few hints on how to work with something like this afternoon. But what I guess I'd suggest is do try and open all that data in ArcMap and see if it is just one rogue data set that appears to be misaligned. If that's the case, chances are that it's the definition for the projected coordinate system is incorrect. Now, I don't know from your question how far away is when you mention that it's a long way away. That's what makes me believe that probably that one was just defined incorrectly, but all the others that you probably have are correct. If it's just one rogue bad data set, I would very much suggest that that is the case, Samantha.
Beth had a question, is there any place you can look up information about different types of coordinate systems, i.e. which ones are common in Europe, etc.? And I'll actually talk about that in our next slide. So I'll answer that in a minute or so.
Dharmendra wants us to see if we can define datum in a more of a simplistic or more of a layman's terms for general understanding. I guess what I'll try and do, Dharmendra, is emphasize to you that a datum is the known point of origin that is used by the geographic coordinate system. I always see it as being the very lowest common denominator of what you need to define a geographic coordinate system or a projected coordinate system. It is defining a known spot on the Earth that you have a measurement for, that then is the basis of the geographic coordinate system, and if necessary on top of that, the projected coordinate system.
Here's some of the resources, and you can see that there's a link on the right, ESRI Support Center, and you can click that on the lower left part of your framework and go directly there. I have two knowledge base articles I wanted to point out. These are available at support.esri.com. The first one is Web Resource Links 17420, and those are basically different websites I've found of use over the years. And then again, Beth had asked, where can I find more information on what different coordinate systems are used where? Several of the links on this page lead to databases, particularly I think there's two for Europe that include Europe. There's another one that has some of the Asian information. And the place I go first is www.epsg.org. That's the European Petroleum Survey Group. They publish a database, an access database of a whole lot of information, hundreds and hundreds and hundreds of coordinate systems and transformations. And we try and use as much of that database as we can in ArcGIS. But it's a good place. You can do searches on the database and say, what's used in Ohio, and, get back 15 or 20 different answers. The second knowledge base article is 24893, which has more information on geographic datum transformations. It's basically has a link to a Word document that has tables by transformation name and then the area of use. So you can search on the area of use and see whether the transformation is appropriate or not. And don't forget that in the ArcGIS desktop help, and the easiest way to get to it is through table of contents and in the map projections. There are several topics in there that are useful. We have PDF files available in ArcGIS installation. There's one at version 8 and there's 3 now at version 9 because we split the file, that have tables that list the various coordinate systems and geographic transformations, the parameters that are in use for the transformations, and the areas of use for both the transformations and the coordinate systems. So those are the first places you want to look when you're trying to identify an unknown coordinate system. So it looks like we're just about out of time, so now I'm going to kind of wrap everything up. For more information, there is a new course on the ESRI Virtual Campus called Understanding Map Projections and Coordinate Systems that was recently published. And there's also a product book for ArcGIS called Understanding Map Projections, which has a lot of good information. And again, the links on the right you can use to jump right to these resources. I also wanted to mention that at the 2004 ESRI User Conference in San Diego, there's a pre-conference workshop on Saturday. It's an all-day event called Grids and Datums, Their Origins and Use. This is given by Cliff Mounier, who is a professor at Louisiana State University. It's a very good presentation. He's done it the last, I think, 2 years. And you'll end up, in the end of the day, really understanding where these things all came from and why they're the way they are. It's very good kind of, throw yourself into it and really understand what is going on with these projected and geographic coordinate systems. So on behalf of ESRI, I would like to thank you all for attending.